Hello everyone. Today I'll be doing my CAD EL, which is going to be a 3D model structure of the water cooler or the solvent cooler, which I had made as my EL for maths, chemistry and electronics. As you see in the screen, this is the model which I had made. It consists of 5 major parts. One is the outer box structure, which you see here, made up of plastic. Second is the metal framework, which holds the entire components, which includes the motor here, the pump, which is present here, the electronic circuit and the display present here, and the pump water cooling cycle system. So we'll be designing this from scratch, including the scene frameworks and the motor and the water pump. So to get started, let's see how we can see this following structure from top. So this is the electronic component. This shape of this box here resembles some type of a trapezium, or you can say a heptagon. So using that we can make the shape, and for the inside parts we'll just be using squares, and even for a display here we'll be just using squares and rectangles and showing how it is. And regarding the wire connection, we'll just be using lines. We'll see if we can use poles or any cylinders, but as of now let's use lines. Now this is the side view or the front view of the product. So we'll start with this view first. This is the best way to start making the product. Let's start making it one by one. First let us make the outer box. Then we make the trapezium structure here. Then we make the steel bars one by one and place it such that it's properly placed. And then you have the outer lid. Then we can make the other fine details like the water pump here, the pipe system and the motor here. Now apart from this, we also have one more part, which is the glass water bottle, which will go inside the structure. I have the structure right here. So I'll be physically measuring the lengths and the widths of it so as to get accurate measurements, and by visualizing it, this will give me a better idea of how to design it using SolidWorks 3D model. So let's start with the first part, which is the outer covering plastic box here. It's basically a cuboid, a rectangular prism, but this part, as you see here, is cut, and this is what we're going to measure, and we'll be cutting that part. Now let me just measure the lengths and the breadths of the following structure so we get some measurements. By the time I'll be opening SolidWorks. So you're using the actual measurements here, converting millimeters. So this is coming around 29 centimeters. So length of the box will be actually 290 millimeters. And then the breadth of the box. So now regarding the breadth of the box, it's coming around 13 centimeters, so let's keep it 130 millimeters. And the height of the box is coming around 17 millimeters, so 17 centimeters, so if we take it as 170 millimeter. Now this gap right here is what we need to find out. Let's find that out. that comes around 6 centimeters, so 60 millimeters. And we also need to give space for the lid as well. So the width of the lid is approximately 1 centimeter. So width of lid is 10 millimeters. Now, as you see here, we have two boxes, so we need to make this ridge as well around it. So let's just, keeping in mind it's just 1 centimeter protruding outside, and yeah, even the width also is 1 centimeters. So the protruding part is around 10 millimeters, and width of ridge is also around 10 millimeters. So using this data, let's start constructing the model. And we'll also need to make this handle as well. So if we see the length of that, it's coming around 9 centimeters and 3 centimeters in this one. So the lid, sorry, the, what's that called? The handle length is around 10 centimeters. Yeah, 10 centimeter, 10, so 100 millimeter. And the width of handle is around 30 centimeters, so 30 millimeters. So using this data, let's start constructing the first model. Now let's go with part first, because we need to start with the parts. So this is what we need to make first, and we'll be accounting for this ridge as well. This is the other ridge, and this is the handle which we're talking about. The blue strip also we can include. Let's try doing the actual box first. So we get this here. So considering this, my view, as this is X, this is Y, and I'm facing towards Z. Let's go with that. So we go with origin right here. So Z view, which is the front plane. So we start constructing in the first plane. So in the front plane, we just first construct the box. So we use smart dimensions now. So as we saw, the length of the box is 290. So let's make it 290. And the width of the box is, the breadth of the box is around 130. So let's do that, 130. Yes, so we get our proper dimensions here. Now let us extrude the body outside. So we need to extrude it. So this is a height. So we need to go with height, So we should go with the height here. So this should be around 170. Yeah, it should be around 170. Now we need to extrude it outside by 130. That is the width. So let's just extrude it out. Features, extrude base. We extrude it outwards this side. We go with 130. Yes. Oh, sorry. 170 goes here, and we extrude the following structure by 130. So this is the box which we are looking at. Now we need to construct the ridge, and we need to make this part curved as well. So for the ridge, let's just make a small cube. Let's go with the front right plane here. So in this part right here, so the height at which the ridge is placed is about 11.5 centimeters above. So let's just take that 11.5 centimeters first at by just taking an arc. Just draw the arc at 11.5 centimeters. That's around 115 centimeters approximately. Yeah, around this part. Yeah, it comes around this part. So at this place, let's just draw a parallel line so we get to know what we're drawing. And we can delete this part right here. So now we need to draw just a 1 centimeter by 1 centimeter box on this side as well as this side. So let's just draw that small box. It goes 0.5 up, 0.5 down. Should be about this much. Yeah. So just zoom in. Smart dimensions should be 10. Oh, sorry. Should be 10. And this should be 10 as well. Right. This should be 10. Yeah. So now we just move this object. So we just mark a point where we get our 0.5 centimeters so it coincides properly, and we know which point we do that. So this should be 5. Let's just see. So yeah, at this point right here, which is coming around 5, is where we need to coincide with this line right here. Is this fine? See that? Yeah, 115. It's good enough. So now we move this entire project, surface, about this point right here. Exactly here, and we cut it. This part is done. So now we just copy this entire project, copy entities about this point, and paste it right here. Sorry, let's just draw the line first. Let's just extrude the line so that we get the point. At this point right here. So, exactly, so let's just trim entities, trim this part out. Yeah, let's just move this point, copy entities. Copy entities about this point, and we move it here. Exactly. So now we just trim out these parts. One's not needed. Just delete it. Yes. So now we know how it is and what we look at. Now we extrude these parts. And this part. Both these parts. by considering that 1 centimeter that side from the middle and this side as well. So it should be, considering the length of this 290, 1 centimeter that side, 1 centimeter that side, it should be 310. 310 divided by 2. Let's just see here, right? So if we read on top, this part is coming 154. So it should be 164. Yes. And if we see this part, 136, so it should be 146. Exactly, similar to this point right here. Yep, we get that point. And now similarly we, oh wait, what happened? Was extrude. Can we copy this? That shouldn't be the case. Okay, let's do it one by one. So this part right here, let's extrude it. See, from top we get 154, so this should be 164, and this part should be 136, so it should be 146. Yeah, should be fine. So we come back to the straight plane again, and what do we had here? Can we move it? Let's just draw a line from. And we have to just do that, and then we draw this part again. Should be 10, and this should be 10 as well. Yes, so now we mark a point. This is phi, exactly. We mark a point at the phi. Now we move this about this point, and we delete this part. And now, based on the following thing, we delete these, and then this whole part should be extruded. Is extruding the same? Yes. What should be 146, and this should be should be 164. Yep. So direction 2 as well should be 146, and this should be 164. Yep, so we have got the ridges now. Now our job is to make that 10 centimeter plane again and do the ridges on this side. So now we take Z plane right here, plane in front, yes. So we just extrude this base on the opposite direction till we approach that point. I believe, yes, this should be the one. Exactly, and now on this side right here, go with the Z plane. Draw the same figure again using the rectangular tool. Confirm, and now the following figure after selection should be extruded on the opposite side till it reaches the ridge. Yep, so it's reaching the ridge. So now we have successfully made the ridge which we needed. And now what we need to do is we need to make another ridge on the top side right here. So what we do is, if there's a way to so now we go back to our plane right here, and exactly at the point, if you see the image, at the point of the interface, that's why the ridge is given. So at that point we draw the square again. We use smart dimensions just to make sure that it is 1 centimeter. and use smart dimensions here as well, just to make sure it's 1 centimeter. Yes, so we have got that now. Now we just cut an arc at 0.5 centimeters so that we know where to draw the line. And then using that point, we draw a parallel line to the surface all the way till here. Yes, so now we remove these dimensions and we extrude it here as well as here. How much do we extrude? Well, here if we see, should be, it's on the plane, so it should be 10. And on this side, one 30, so it should be 140. Yes, so around 140 should be the edge. We come back to the same plane again, and then we draw another square. What happened to the line? Okay, so 10, 10 right here, and 10 right here. Mm, 10 units. Yes, okay, so now we just delete it, and the same thing we do is extrude this part by 10 on this side, and this goes to 140. Yes, alright, now we come to the right plane, where we draw a similar square of 1 centimeter by 1 centimeter, and this time it's placed here. We extrude it. How far do we extrude? Till it touches the surface right here, and till this touches the surface right here. Is that a gap? Hold on. Why is there a gap? Okay. Alright, this is about that. And now we come back to right plane again, this part right here. We draw another square at this point. Yes, exactly. And now we extrude that. That goes correct too. I think we best do that. Right. It's plain. It's just go with 154. So let's extrude this part all the way till this part right here, and this goes all the way till this part right here. Yeah, this is fine. It's fine. Now we come back to this axis again, right plane, sketch, draw all the way here. Features, extrude the base all the way till the edge right here. Oh wait, it shouldn't go that much. It should just go till here. Yeah. And this part should go all the way till the end of this. Yeah, which is this much. So this becomes a plastic box, which you see here. And we need to make this hollow now and this ridge right here. Right, so what we do is we go back there. So we see that it's 1 centimeter this much, right? So we take the top plane, go to x-axis. We now check smart dimensions of this part right here. Oh, sorry, I'll just save it. So we'll create a folder within inet. So we'll do one thing, we'll do a document. Just create a new folder called CAEGEL. Open. Um, CAGEL, and this is called plastic outer box. Save. So yeah, so it's saved now. So top plane, yes. So now we take my dimensions. We measure this part. It's not measuring. Why is that? So we draw a line, top plane. No, we need not draw a line, we just draw a box. So as we see from the following sketch, it's the length of the box is 290 millimeters. So 2 centimeters on the opposite side will lead to 310. Right? So if we see the box from the top plane, we see that only the ridge is left and the inside part is carved out. So we take the part as 290 and 130. So hence, let's do smart dimensions. Let's make this 290, 290, 290, 290. Let's make it 290. Yes, and we make this as 130. Right? So, but it should be at the middle, so we need to move this a bit. So, should we move to this part? Just remove these parts right here, we don't need these. Now let's measure the center of this. Where does that coincide? Yep, so it coincides right there. So we trim these parts, trim this line as well, and now we move this entire thing such that this part coincides with this. Now let's trim these entities. Let's go back here, remove these smart dimensions, and now what we do is, based on this, and this, let's keep a very small, let's not even 0.5, let's just keep it as 0.5 millimeters, right? So we'll just do that. Come back to smart dimensions again. So what we're doing right now is we are considering a 5 millimeter thickness of the plastic box. So hence this part right here becomes 280, right? And this part right here becomes 120. It's not 5 millimeters, but to be very precise, it's around 0.25, 0.3. So just keep it 5 millimeters. It's too thick. 5 millimeters too thick. Or we'll just keep it as, it was 290, right? We'll just keep it as 2.5 centimeters. We'll keep okay, 1 millimeter thickness. 1 millimeter thickness. So it should become 288. And this part here would become 100 and, sorry, 128. Yeah. So now we find the center again. It's quite a process. Use this point, join here, trim the additional entities. This is our center right here. We don't need this, we don't need this, and we don't need this. Now draw the diagonals of these points right here. Trim these entities. We don't need these. This line's not needed. Now we need to move these entire thing. Move with respect to this on this. Yeah. Yep. So now we just trim these entities. We have maintained a 0.1 millimeter thickness. And now, sorry, trim this. Now, based on this, and this, we make an extruded cut. How big is the cut? Well, here crosses the boundary. Hold on. '79, right? So we keep it as 78. Put open and close counters. Okay, we'll just make this down right here. So this should be 91. Let's make it 90. What's wrong? Yes, so yeah, this is what I wanted. Yep, so now let's go to this one right here. So if we see, this is coming at 79, so we maintain this at 78. And this one right here, this is coming at 91, so 91. Oh, and let's just make that 78, and this part let it be over. So now we can see the hollow structure present on this. So this becomes a plastic lid. Now this has formed. This part has formed. Now we need to make the lid. Now for the lid, let's have to choose another part. So we'll do that. So before that, let's just make the surfaces of the following lid. This is thick plastic, right? So if you just see it, this is thick plastic because you have two boxes. So let's just see if we have appearances. Yes, you have plastic. Just used high gloss. Just needed transparent plastic, maybe low gloss, soft touch texture. Why is it gray though? Yeah, we'll just use the entire thing to be one, right? So can we do this? Just this part? Yep, we can do that. So yeah, should be transparent. So let's just translucent, right? And these surfaces right here, let it be with my mouse. Um, take two and let this, 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 and this be stick one. And now coming to the ridges, which are these parts right here. These are some high grade plastic right here, right? This is thick, extremely thick plastic. So let's make it HDP. Yep. So this is our plastic model. Let's just save it. This is where we keep all the plastics. Now here, let me try to fillet this region, this region, and just try to fillet it. Fillet the region, similar as this. Exactly. So yeah, this part and this part as well. Just fillet it. This part is not getting to record video. I'll, either mode. Yearly. Uh, uh, this. I'll mode. ನೀವು ಮಾಡ್ಕೊಳ್ಳೋಣ. I have to record audio also. So these two parts are filleted. Now let's do with the upper parts. Let's just fillet it. We need to record ಆಗ್ತಾ ಇದೆ audio. So this part is filleted, similar to this part and this part. So these are done. Not understanding what this part is. ಹ್ಮ್ ರೆಕಾರ್ಡ್ ಆಗ್ತಾ ಇದೆ ಕ್ಯಾಮ್ರಾ. What is this line? It's just a plane. Alright, so this is our part right here. Now we build a new one. So now the plastic box is done. Now we need to build the metal frame structure. So if we see right here, it starts with a rectangular base followed by two rods here having a plastic interface on this part, and then you have two rods going down, and you have the same structure here as well, where you have two small ones and a bigger rod is placed at 90 degrees. So we need to measure these parts now. It's coming around 20 centimeters. And the height, it's also is coming around 20 centimeters. Now coming to the internal rod, which is this part right here. This is coming 30 centimeters. And this part is 8. Thickness of the rod is 3 centimeters. Thickness of this rod is 3 centimeters as well. So let's start with the first rod. The best thing to do is start with you have to do parts here, right? There's not much I can do. Let's check. Let's make a base and then we can extrude it. So best thing to do is top view. We'll just go with the top plane right here. So when we see this length, which seeing this length right here from here till here, it's about 20 centimeters. So we need to draw 2 rods, which is 20 centimeters apart and 3 centimeters in thickness. And the distance between them is about 10 centimeters. So there's a 3, so there's a 4 centimeter gap between them. So this part right here is 10 centimeters, so 20 centimeters, which is 200. Sorry. And this part is 30. Now measuring this part should be 40 centimeters. Now before we do that, let's just extrude this downwards by 3 centimeters. So this goes by 30. Yes. And now come to the top plane itself. You can sketch this part here. Oh, what happened? This should be 40 centimeters. Now we just copy this part at this point right here. Should work. Yep. And we move it to this point. So what happened? Okay, we'll just draw the figure. It's fine, no problem. We can use smart dimensions and I can do it off. So this should be 200. And this part should be 30. Let's just remove these smart dimensions. Now we extrude this part right here downwards, same distance as we did this guy. Yes, so we have two identical rods placed apart. So you can see this is hollow. So we need to apply a textured metal. We're gonna do it. So now we need to make the next part, which is a full plastic plane covering from point A to B. So it starts from here all the way from this point and goes all the way till this point. Yes. Yep, it's exactly like this. This is plastic. So let's save this, right? So this is plastic. This will be the metallic structure. Now, coming to the top plane again, we have another 3 centimeter protrusion from both the rods coming like this, 30 by 30, and that's going down. So let's do that part. Let's just so if we see the figure right here, that length is around 20 centimeters. But if you see the height of the box, 170, so that's covering up, it's going 3 centimeters above. So let's just take this part, extrude it downwards by how much is that? 200. 100. Yes. Exactly like this. There's a ridge right here. And where did that plane go? Okay, it's fine. We can draw it later. Top plane right here. Yes. So sketch. Draw from here again. Let's just draw a straight line so we know till where we draw. I may not measure that part again. Yep. So trim entities, trim entities. This is our plane right here. This also is extruded downwards all the way till 200. Oh, multiple sketches. Where are the multiple sketches? I'm just selecting this plane. Extrude it downwards. Downwards all the way till 200. Yes. So this is our metal framework, which is ready from the top view perspective. And this part. Now this part is done. Now from this part we need to draw another metal framework. So it looks like this, right? The same procedure. It's a cube. So we need to measure that height at which it starts. So it starts at 5 centimeters. So it has 50 millimeters above. So what we're witnessing is we take the front plane. I'm sorry, the right plane. Go here. We sketch by joining these two, and from this we just go up. Let's just check at what distance we get 5 centimeters. That's 50. Yeah, 50. So this is the point where it starts. This is the point where the cube starts. So just take this line. We can do a straight line right here. A straight line all the way that side. Now let's start drawing the cube. And this entity right here. Sorry, what was that? Yeah, this point right here. Can we take this point? What's the dimension of this? Why is it 30.1? It's 30. And this one is 30.1. Okay, it's causing a bit of trouble. Alright, not a problem. Now let's go back to the right plane. Right? Yeah. So now from this point right here, this gap is 20, right? So it should be 20. Let's just stick to 20. I want to set it at 20. Isn't that working? I mean, what's the problem? Right, so 30 is done. And now what we do is we delete this and then we extrude this. The problem is it shouldn't. Hmm. No, 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 this is not what I want. Okay, so this is the structure right here. Let's extrude it. Now this part till here is about 66 and this goes to 96 right here, and now from 96 that measure is close enough to 290. So 290 plus 96 is equal to 6. That was 9, 18 on carry, 386. So it should go up to 386. Now let's just extrude this part. It should go up to 386. Yep, so this is fine. Now same thing we do here. Right plane. Just do that as well. This should be 50. Let's make that 50. Yep, so it's 50. Now we take this part, go all the way up. Let's extend this part. Delete this. Trim entities. Oh, now we just draw a line from here. Now just trim entities. Now from here we draw a square. Should be in line with this. Okay, there's no line. We can use smart dimensions. And it should be 30. Yep. So this is 30. So all this is done. Why is this still there? Okay. We extrude this part as well. This is go to 386. Yep, same parts here. So this becomes our metal framework. Now here there is another part for support. There's actually there are two interfaces. There's two stands here. There's two stands, and there's a plastic surface here. And these are two ball bearings. There's one, two, and three ball bearings just placed, and there is an axle after that. So that we can do it. That's not a problem. So now just save it. Right. So now we come to the front plane. So here, actually we go to the top plane. Right? Top plane. Yeah. So here, from here, full 30. So this goes to 30 centimeters. So I'm sorry, 30 millimeters. Here, yep. Delete this. Now, where is this formed? Has it formed in line with this? Yeah, it's formed in line with this. The problem is, can I move it down here? Can I do that? No, I don't want to cut that. Okay, I need to finish that off first. Okay, let's extrude this. Down there. 'To the top plane again. Now we draw another square. What is the problem? And I select a plane. .30. Okay, so this is 30. Now I delete it. No, it's formed on this. How is that? I need to select that. Okay. Oh, save, save. Okay, okay, understood. That is why. Ah, shit. Any. Okay. Move that. Move that down there. That should come. Already. Yep. Okay, let's just remove this part, right? So, Okay, start now. Now, what we do is take the top plane, we draw, this is a rectangular pole, so this doesn't involve much, so just halfway. This is 30. This 50. Yeah, so now we remove these parts. Now we extrude this downwards till what point? Till it reaches the base, which is 200. Yep. Now this side we do the same. The top view, come straight there. Take sketch. Here, turn to points. This is 30. And this is 15. So this is done. Now we just move these smart dimensions. And we extrude this downwards. And if we see from this direction, it should touch the floor at 200. Yes. So this is our metal framework. Now we are missing one more part, which is just the plastic top here. We'll put that as well. So it starts from here. It's all over here. And we'll just extrude it by 1 millimeter just to show that it's there. So extrude upwards by just 2 millimeters. Let's do it. So this part here is plastic, so we'll just go to plastic, and it's soft touch. Yeah, let's low density plastic. Let's go with this. Yeah. And now all these surfaces right here, these right. All these surfaces. Is everything selected? No, these two are to be selected. These, and what else? This part, and Slow things down. I think you selected most of them. Yeah, it's right. So this one here is metal. So metal we this is has steel. And what type of steel? Mm, chrome. I think the best thing we can go with is steel and kernel steel. Yeah, this is the best thing we have to show. I mean, it is a mesh, but yeah, that's how we can show it. So now, so this part is done. Let's just save it. This covers the metal frame and plastic box is done. Now what we need to do is the motor, the pump, and this rod right here with the motor. That's the most important thing which you have to do right now. So let's start with this part right here, the display, right? So how is the display? It's like this, just like a trapezium, and it's extruded out. Let's just check the dimensions of it, so we don't have any doubt. So seeing the dimensions, it's coming 9 centimeters, which is from here till here, and about 18 centimeters from here till here, right? So, and the point at which the curve starts occurring is around 8 centimeters out of the proposed 6 centimeters. So length is 18, as we saw. Yep, it's 18. The full width is 8. But the curve starting width is around 6. So that includes the display and everything. So let's try doing that first. Right? So we start with a new sketch. New part. Okay. So it's a top view, right? So we go to top plane here. So if let's just draw the rectangle first. Perfect. So this is coming around 18. This is 180. And this part is coming around, you see, 80, right? Yeah. So can we use it's just a parabola, right? Let's consider as a parabola, but it's a trapezium, so at some point, okay, it also is around 6 centimeters from the. Okay, so this is 9, I'm sorry. This is 90. And that occurs at 5 centimeters. So Okay. And this is occurring at 5 centimeters from here. So let's just mark that as well. We made entities about this point. Yep. So now we have things, right? So spline. So we have constructed the um, tool right here. So the trapezium kind of shape which we wanted to have is present right here. So yeah, this is the shape, and this should be around 80. Yeah, this should be 80. Yeah. So now what we need is the height which goes up. So that is around 4 centimeters. So this is how much is that? For yeah, 4 centimeters using the tape. So And there's a ridge around that, and there's a handle as well, so that's fine. That's not a problem at all. So we need to make the ridge now. So for that, we just use a square base right here. Oh, sorry, what happened? Yeah, right plane. Oh, I'm sorry. Yeah, square base right here. It's hardly one, like yeah, two. Now we extrude this till it reaches. We'll go both directions, right? So let's go here till it reaches this point. Yeah, and this goes all the way till the other point, right here. What? 86. So that's the ridge right there, and then right below that, right, you just have a handle. So just show that as well. You just draw that off with a square right here, keeping in mind the smallest details possible. So it doesn't have any measure, so just extrude it. Goes all the way till the end here. So protrude out a bit, and this is just like tiny portion coming out. A little more. Yeah. How about this much? Exactly like this. So this is a box ready and done. Um, Inside stone, right? So now we need to make these squares. So we have 1, 2, 3, and you have 4 right here. So we will just take squares size. Need not be specific, but we'll try to be that. We'll try to be a bit. What do you say? Sorry. We'll try to be a bit. Take approximations and do it. Positions as well. Yeah. So here, this is one part. Um, this is specific, right? Now, is that a part? Is the third part? Okay. So here goes the other part. Still close, still close. And is a display. So now we start protruding the things out. Extrude this. Not all, not all. Let it be about, how much is this? Like 3 centimeters? 3 centimeters sounds good. Well, let's do one thing, right? Let's just make it out so it's seen better, and then we can modify it later on as well. So extrude the bases. Just make it look out. Like it'll look nice. It'll look nice. This is 40, so 41, 42, 1.5 centimeter outside. Sounds good. Yep. So now sorry, this, 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 and this, and this are all pure plastic. Now, how do we choose the plastic? Here we choose acrylic. So yeah, this is a bit acrylic. No, we will give it a touch, right? White satin. Oh, I need to select them again. Oh, my bad. So these things right here are hard plastics. Oh wait, what was that? So these are hard plastics, so we'll just give them the gray finish. And look, yeah, and this right here, this is something red, and this let's give them a metal finish. So this, if we see the color in the picture, it's our blue, so we'll give them a blue metal. Let's see if it's there. Exactly. what I was looking for. And this one is about purplish color. So let's see what we get in that purple. I'm not sure I'll get many. We'll give it cast brass. It'll look nice. And this one is pure red, so this can be anything. It can be copper. We'll give it copper. Cast copper looks good, right? And this one right here, this is our display. Oh, cast is not looking good. Okay, just give it. We'll just give it copper. Satin finished copper. Oh, sorry, this is not copper. This is our, what do you say, our purple finish, right? Yeah. This is not going with the plastic. We'll just go with silver. That's silver. Oh, this also is not good. Some different color. So it's just like distinguished, right? We're not trying to decorate. We're just trying to distinguish it, so it's more recognizable. Okay, we'll go with bronze. Why not? Yeah. So this is our brain of the um, model. So let's just save this as brain. Now let's see our model. This is done, this is done, this is done. Now the motor, the axle, the pipe system and bottle are left. Four things are left. So let's design the motor and the axle system together. No, motors has to be different, right? So we'll check which of the motor. And this has to be separate. So let's design the motor. First we need to design these ball bearing. We'll design the ball bearing first, right? So for the ball bearing, let's start with a new figure, a new part. So front plane. If you see the diameter, it's the radius, right? So can I start from beginning? Yeah. So we'll just do it again. Radius is hardly one, so it's 10. And using the same center, let's go another one with 5. and this distance right here is about 1, so let's go with that itself. 10. Yep. Oh no. Exactly. Now from here we need to do some more changes. Let's just go to the front view plane. Yeah, this part right here. Yeah, so front plane. Now here, straight line goes there, and this is the like structure, like so. Bit this side, and then you have all that. So just try to do that a bit, whichever we can. Goes all the way on top as well. So for that we construct another circle, I guess. Just yeah. Now this distance here is about 2, and this part here is again we need to mention as 2. Okay, goes to 2, modify. Yep, so now we draw a line down. We just remove this. quite confusing. Yeah, so now just draw a line down, and from here as well, just draw it down and trim these entities. So now this part here, this is 1. Similarly here, this part is 1. Oh, sorry. This part here is 1. So now just delete these dimensions. So this part here, this is 4. Oh, no. So this part here is 4. 4, 4, 4, 4, 4, 4. Yep. So now what we do is remove these dimensions. Now comes the difficult part, right? So now what we need to do is we need to draw an arc from here. So we need to choose this. So this is our ball bearing structure, which we have obtained as of now. It's a simple structure, but yeah, we can just tell that. Um, guess we're missing one more part. We'll just do it off. Might take time. So let's just um, take this. Yeah, over here. Yeah, so this part also we need to extrude. Uh, what's happening? Rebuild errors. What errors? Oh no, no, it's crashing. Result in zero thickness geometry. Hold on, let's just do this, right? Yeah, so this is our ball bearing right here. So um, oh sorry, this, 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 oh sorry, this, and this, and this, and this, and this, and this. Yes, all these. All these are some random metal. Wait, hold on. It's a steel. It's like, yeah, it's similar to this material right here. Yeah, exactly similar to this. This, whereas this, and this are proper steel, polished steel. Yes. So this will go as our ball bearing. So file save as ball bear. Wait, it creates a small figure. I don't know. Okay, that's nice. Okay, ball bear is done. Now comes the part where we need to do a lot of work. The motor. So we have made this ball bearing. So this belt, this motor, and the rod. That's the part which is quite difficult. So so if you just see it's a cylinder fitted with another cylinder through that in a couple. So let's do that, right? So front plane, diameter of that, it's 5, so 2. We'll go with 2. Um, 5 centimeters. 50. 50. Yeah, it becomes 50. So this is done. Now from here, we come back to our top plane. Sorry, front plane. Come back to our front plane. Now here we draw having 1 centimeter radius, and that fits through the 5 centimeter radius of that. Now 1 centimeter radius. 1 centimeter radius, right? So this should be extruded this side, and how much is that? It's about 3 centimeters, so 30. So about 30. Nice. All right. So now, coming to the front plane again, we have to draw a 5 millimeter radius. Starts from there, and that length from the motor end through the bearing and till the is 5.5 centimeters. Okay. Yeah. So this is our motor. We just go with top plane. We can draw 2 pinouts, like what do you say, the electrodes for the motor can be drawn. Small cube, that'll work. Line itself will work. Extrude a bit of, oh my god, a bit. Yeah, only that much. Oh no. No, I don't need that much. Extrude the entire square. Yeah, nice. I wanted that. Okay. Just 2. Yeah. Save. Now, this, and this, and this, and this are copper. Polished copper. Yeah. This one remains the same as this. This one's quite rigid, so let's just put it as aluminium. I guess it's aluminium. Brush course aluminium. and this rod here is like uh, what's that, chrome. So yeah, this is a motor. This comes here that we can do. Now we have to make the couple, the belt, and the rod with this one, then the bottle and the pump with that lid. Okay, we can do it. File, save as motor. Open new. Open new. Open new. What happened to this? Hello, hello. Okay, it's working. Part. How long is the recording till now? 2 hours 24 minutes. Okay. Oh my god. Okay. Let's try metric. Is it fine? Okay, it's fine. The belt has to be made. Okay, understood. So this, that is 5 centimeter. That's around 1, similar to that. Okay, so let's just go with sketch circle. We have our 1 centimeter circle ready. Take it up. Okay, and that goes about, how much is that? 1. Okay, not bad, not bad. Extrude out, extrude it this side, bro. Yeah, 1. Yep, take it. Now come back to the front plane again. Is it correct? Yeah, it's correct. Front plane. Sketch circle again. This time it's 0.5, like 5 millimeter. And this side, this time I have to extrude it this side. About, how much is this? That's also 1 centimeter. Yeah. Just extrude it by 1 centimeter. Yeah. Now through this, there is a belt which is going down. Now how do we draw that? It's a 2 millimeter thickness belt. Okay, so we'll just go to the front plane. Go to the front plane, yeah. So, yeah. Arc. What happened? Now, what we do is go back to the front plane. We draw another arc which goes from here till it goes that much. Let's keep at 6, right? Just showing it how the belt system works. So 6, take it up. Um, shouldn't it come at 6? Yeah, it's coming at 6. So just delete this part. Okay. Now come back to the front plane. Continue drawing a line here. Yep. Uh, trim this, trim this, trim this, trim this. Join these two. Extrude it. Now comes the part where we need to do some experiments. So we need to go down. Um, oh my god, okay. So we go down there. We sketch the rectangle. This is the plane we want. Sketch this part. Sketch this part. Yeah. And extrude it downwards. How down does it go? It goes about 120 down. From this one, it goes till there, right? It goes about 11, 11, 11, 11. So this is the top part, like this will join to that and they'll come, and from there we need to ignore the couple, pass that through a rod and then put that. Hmm? So how we do that is extrude that part and then extend the rod all the way there. Yeah, we extend the rod all the way there, put that to this one, and then washers will come. Nice. So this we leave it as it is, but now we do some changes. This part is fine. Let it be fine, right? This, and this. This is proper. Let's just make it polished brass. It looks nice. And this, 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 this. Remember, polished brass and normal are pure carbon. This rubber. Exactly, exactly. Okay, nice. This is nice. Okay. This will save as, what's that? What is it? Save. This is saved as upper motor clamp, right? So now we do the receiving end on the other side. Oh, wait. I already saved it, right? Yeah, sorry. File new. So this becomes the main part, and the lid, let us see what we can do later. So it's just a plane which we are keeping on that. The main part is the pipes and other things that we'll try to integrate and do it. So now, again, come to the front plane. This time it's going upwards, right? So what we do is first draw the 1 centimeter circle. 10 goes there, and that extends this side. 10 extends that side, and that 0.5 goes all the way there. I'll tell you how that works. So now features extrude. How far is it going? Should go 10. Yeah. No, wait. Yep, 10. Alright. Now this side, the plane goes this side, right? Front plane. Front plane is this side. Yeah. Alright. Front plane is here. Now what we do is we draw the 0.5 centimeter, so that is 5 millimeter circle, right? And that extrudes on the other side, which is this side. But keep in mind, now it's a tricky part. Features extrude this side. Now direction 2 exists as well. Direction 1, 10. Does that show it done? It's done. Direction 2 is the situation now. So from here goes all the way there. So that's 26 from here. So 260. Right? Now the receiving end. Receiving end is on, yeah, so that's right. Yeah. Receiving end, we start this one. Front plane. Right? So receiving end, 7 and 6. So we start with a sketch, just draw the line. Draw the line all the way there. All the way there. After drawing the line, we draw the circle. First 7 centimeter circle, and then we draw the 6 centimeter circle, right? And receiving end, so top part should be cut off. So keep in mind that other than that shouldn't be cut off. So cut off, and this, this, this is cut off. Why isn't this selected? Oh, I'm pressing caps lock. Okay, sorry. Extrude. Right. So now, what is the material of the rod? Where's the rod? Oh, you're not made the rod? No, the rod is that. Yeah, this rod is that. This one is polished brass. So this one here, brass, polished brass. Yeah. And this one is this one, this one, this one, this one. Things covered? Yeah. This one is rubber texture tire thread. Yep. So this is the receiving end of the this one, right? So so if you just see the image, right? This one here, this is the rod which you have made, the receiving end, the top end goes here. And now we make the washers. After making the washers, the only thing left is the pump with these and the outer covering. And then we arrange things, right? So let's start with that. We're 2 minutes 40 in. Okay, so part 7, we have to save this. What is that saved as? It was saved as upper motor clamp, right? The lower motor clamp. Okay. Now we need to make the washer. Washer, we're keeping 4, but the thing is, it's quite difficult to make it. It knows a lot of circles and things. So see how to make it. And it's blue rubber. See if we find material like that. So if you see it here, right? This is a washer. So let's see how to make it. Now we take the front plane first. Go to Z axis, front plane, right? We go to. Sorry, what? No, no, no. Yeah, so it's around 1 again, the largest circle. So this goes 1, and then you have 8, and you have 6. Then you have another circle, which is 8. And you have another circle, which is 6. 3, and then the 5. Now you have a 5. That itself is like it's, it's literally like 5. Just keep it 3. No, it's not keep it vertical, let's keep mid plane. Yeah, so first we extrude this part. This comes around 3. Right, so now we go to the front plane again. So we draw another circle. That was 1, and then this is 8. And then we draw another circle, which is 6. So now we have the final thing. So we have points, we have 6, 1 here, and then in between the final one, which is 5. So now if you go to front plane and you want to verify, like if it's really 5 centimeters or not. Um, 5. So yeah, that's 5. So now is the part where we choose a material. All these are same materials. It's rubber, but it's blue. So let's see if we have anything like that. Gloss, matte rubber, organic, orange juice, fabric. We can try this. This works. Yep. So this is our washer. Document cannot be empty sketch. What is the empty sketch? Washer. Would you like? Sorry, what? Oh, it's all lagging. This is fine. Like, yeah, washer is fine. Okay. Now comes the last part, which is the motor and this one. A motor is quite difficult to just. It's just an additional feature, right? See, the thing is, this is what is the motor. So instead of that, let's just make the bottle so that we can place it on that and then the lid, right? So we just do that. This is quite. Um, I don't know how to build this. It's not showing the proper deal. So yeah, we'll just go with the bottle. So the bottle here, what I have, new part. Okay, okay, bro. Okay, the bottle. Where is it? Yes, the bottle. This is the bottle which I have, which we are using in a model. So the diameter of this is around 6. So we need to take a 30 centimeter, 30 millimeter. This one, and the cap is also the same. So now the length of this entire thing is 20. Till the cap it's 70. So let's just write down that data, right? So bottle radii is 30. uh, Total length is 20. Cap length is 30. Oh, sorry, 200. And the cap is plastic, it's blue, and yeah. So how do we start? Start with the front plane. And the thickness is negligible. It's take 2 millimeters thickness. No, 1 millimeter thickness. Because 2 millimeters is not even do anything. 2 millimeters thickness. So 1 millimeter thickness. Let's write off 1 mm thickness. So now front plane. The entire ball is 30. So start with 30. And even the cap. Is the cap solid or like how's it? The cap, let's assume it as a pure solid, right? So now we're making the glass. So we take the section again, draw it. This time the radius will be 30 minus 2, which is 28. Exactly. So now what we do, we extrude that side. Extrude. This time we from lines line. How much is it? 30. So 170. 170. Oh my god. Okay. 170. Say, Let's draw that circle later, right? So first we extrude this part on the opposite side all the way till 170. Yeah, nice. Now what we do is go to the front plane, go here, draw a circle of diameter 28, so radius 28. Keep it there. And now this we do an extrude cut side till 169. Will it form solid from here? Yes, it's solid from here. All right. Now, no. Come back to front plane. Sketch the center. Yeah. So this goes up to let me just change the radius of this. It's going to fence. So doing this is make it 30.5. Blue plastic. Oh no. Normal glass. So this is our bottle right here. So just save this as our bottle. So bottle is done, framework is done, rod is done, ball bearings are done, motors are done, brain is done. Outer cover, top cover. 25, 14. Okay, now last. So the thing is, you see these things, right? That's the important part. The hooks which keep the bottle placed there. So that's what we have to design now. It's the final part. The reason why we're avoiding the water pump is it's quite complicated and there's no way for us to properly arrange them and do things. So that's why. Um, so what we'll do is we'll just choose a new drawing. Now, how we do that is we just go to the top plane, right? Let's go to the top plane. Now we just saw it is 140 is to 25 using this. So 140 is 25. We'll just sketch it up using the paper and sorry, one minute, rectangle. So 25 will come up to 250 on this. So 250 and this is, how much is this? 140. Now we need to divide it into hold on, I'll tell you. 140. 140 comes there and that comes there. So now 250 is divided into 3. 250 divided by 3 is around 80. What do you say, 80? Do one thing, right? We'll just take it as 240 and work on, because why not? 80, 80, 80, 80, 80. Or it has to be a multiple of 4 actually. It's like if you take 240, so it'll be 6 6 6 6. That works. So we'll do that, right? 240. I'll indicate how it works. All right. So come to 40. Yeah. Now, how does it go? How do you actually do it? Let's just draw the middle line from this part all the way till here, right? So now what we do is we start marking 6 6 6 6. So how we do that? Linear sketch pattern. Oh no, I forgot. Okay, so we'll just draw the line parallel to this, and we'll be like smart dimension. All right, it should be 60. Then we'll be like one more line beku, so we'll draw it somewhere here. Oh, that should be extruded 1 millimeter, then that should go down. Oh, stop it, stop it, Smart dimension. This goes around 60. Okay, and do it off now. Stop, stop. Stop. What is this? Remember this. I don't know why it is glitching. Okay. Mirror entities. Mirror about this. Okay. Now we need to draw squares here. To my 140, 70, 70, then 10, 10, 20, 20. It's like 1 centimeter, proper 1 centimeter. And that is around, hold on, 3 centimeters. So this the width is 3 centimeters and length as the length is 3 centimeters, width is about 1 centimeter. So we can draw a find the midpoint of this. Why are bottles appearing out of nowhere? 30, okay. Stop. Escape, bro, escape. Okay, now what I should do? Trim entities. Sorry. Smart dimension. This comes around 30. It's 3 centimeter, right? So yeah, 30. This comes 30. Then holy lord. Hold on, hold on. First, remove all these unnecessary things. Oh, what are these? Who asked these? Oh no. How do you select? Snaps. Select, bro. Select LD. Chiller mode. So now we are duplicating it across this line so as to bring it here. Sorry, mirror entity. So now we are mirroring about this line so as to get it there. I don't know what those are. Okay, anyway. Now we just draw a line here. I'll tell you why. Now I'm done. Uh, so we have to mirror entities here. So this measure is 30. We ensure that it is 30. What is this? It's 30. So now what we do is we delete this. Yeah, so now we now we mirror entities about this line, ticket, delete this line, delete this line, delete this line, delete this line. So this is what we have come up with. Now we need to extrude these. How much should we extrude? Let us see from this thing. Just extrude ಮಾಡಬೇಕಂತ ನೋಡೋಣ 9 including 1 centimeter of that. Okay, so this should go 1 centimeter, that should go 10 centimeter, 10 centimeters. Skip. Yo, what? What? Hmm. Okay, do it off. Do extrude it off, it's fine. Okay, now what we do is sketch center line, center line, midpoint illide. Right, so now we have to do draw center rectangle from midpoint. It goes all the way till there, right? Where the this one is up about how much? How much was that? How much was that? 25, 250. Wait, first we need to check if the bottle fits within that. Bottle radius is 60 now. Will it fit? Bottle radius is 30. Diameter goes up to 60. Will it fit within that? So now um, trying to cut these lines right now. No, why it's not happening? Yes, cut bro. What is your problem? I will delete it off. Escape, escape. Delete. Okay, I need to ensure that this gap is 60 so that the bottle fits. So for that, let us ensure that the gap is 60. How do we make that? Will it allow me to do it? I'm not sure, but let us see if it works. If it works, well then good. If not, I need to do something else. Either I reduce the bottle size or I do this. What is it? Over defined value. Not a Okay, let's see. If it doesn't work, then I'll reduce the bullet size. As of now, let's arrange everything and let's check it out. So the problem was I didn't ensure 60 diameter, so now it's quite difficult. It might go in, so I can use frosted glass for that, so ensure that nothing happens. But still, plastic. This is plastic. This is transparent plastic only. So this is hard plastic. So all these are hard plastic. So that's why it'll be more solid compared to. Let's make it what type of other plastics are there? It's not wax. I don't love white wax. Okay, it looks it's fine. It's fine. This looks fine. Okay, now this needs to be saved. Lid is what it is saved as. Okay. Now everything is saved. All the things are saved. Now the thing is to arrange. For that, let us open new and let us do assembly. Now all the making is done. Now we need to assemble it properly. Yep, I need all of this, bro. What do you mean default? Calm down. Okay, select the component, insert. Okay. Wait, calm down. No, 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 no. Wait. Can't do this. Open new. Close. Lid over now. Where is SolidWorks? Ah, here. Oh my god. Oh my god. Okay, file. New. Assembly. Okay. Okay, so let's go full screen mode. What is this? Okay. First is the outer lid. Where is the outer lid? It's not even there. Plastic out box. What is that? Okay, now how do I get? No, where was that? How do I get other parts? Now the metallic structure. Hold on, hold on. Control Z, control Z. Insert component. Now I'm inserting the metallic structure. So first thing is go YZ axis. It's not getting like how do you make sure it fits properly? No, no, it's like it's working, but what? Oh, inserting component. Why? Why? Why is it? What the hell? Why is it like that? Exactly. This is what I want. Smart fasteners. Oh, nice. Nice. I like this. Okay. Yeah, so exactly what I want is this. Perfecto. Perfect. Nice. Okay. Escape. Yes. Nice. I like this. Yes. Okay. Now, insert component. After this, this will be the brain. Yes. Now I want to move this component. Calm down. Move up. Nice. I like this. Okay. Now the motor. Escape. Um, motor. So we have arranged the motor, the brain of the computer, and the what do you say? The ball bearing. Now coming to the part of the upper motor clamp. Now this one I have to something like this. I have to do. We'll move it. Before that, ಒಂಚೂರು ಒಳಗೆ ಹೋಗ್ಬೇಕು ಒಂದು ನಿಮಿಷ. Because the upper motor clamp, it should bond with that, so just move this component a bit inside. Yeah, so now okay, now we need to choose that lower motor clamp. Holy Lord. Okay, now how do I move this? hold on. It's here, no? She just touch it. Yeah, fine. Nice, no? See. Now there is one more this one here. We need to put the washer here as well. So one more washer we need to put. So I'm sorry, what am I doing? Ball bear. Insert one more ball. Two more ball bears should put. One more ball bear. One more. Because sorry I couldn't do the pump. It's quite difficult. It's one more additional feature I have to do. It's really difficult. 5 is done. Now, what do I do now? Move component. View from top. It looks good. ಚೆನ್ನಾಗಿದೆ ಆದರೆ ಇನ್ನೂ ಆಗ್ಬೋದು. Okay, it's fine anyway. Can't help. Now this one should go here. This should overlap this. So this is done. This is done. Brain of the computer is done. Yeah, most of it is done. Now comes the washer part. Now washer, we as the image shows here, we require 4, right? So we'll be inserting 4 washers. mm, what's the screen recording? 3:45. Yo, okay. Now 15 minutes will finish it off. Now I need to insert one more washer. Sorry, 2 more washers. Then one more washer I need to put. So now I need to move them. 15 minutes. Where did the other washer go? Hmm? Yes, so everything is done. Now the main part, which is the bottle. So once the bottle is put, and then you just have to put the top cover, then we are done. Bottle, where's the bottle? Yeah, bottle. Why? Okay, now comes the final part, which is the top lid, upper lid, upper lid, upper lid, upper lid. Where is it? Lid. I'm just putting one layer of some plastic so it looks like it's under something rather than just normal plastic. So I'll just try to put something like this. Yeah. So there you have it. That's the final model of my water cooler, which in real life looks like this. You can be the judge for comparing how it looks and how it is. Now, before we do anything, let us first save this. Oh my god, okay. So, what do you mean rebuild? Okay. Um, Final assembly. Save. Let's just save all. So, just have a look at it, and it looks nice. There are a lot of components involved, and it does look complicated. But yeah, it takes a lot of time. It requires some practice. So yes, this is my model. Let us now make drawing from the assembly. Now for that we go to A4, we go to custom, we type here 297, type here 210. Okay, here you will get the, what is this? Oh my god, okay. So I just want the top view, top view of it. Hold up, calm down, calm down. Top view, front view, the right view, and the isometric view. So there you have it, the final model with the given figure. These are all the various components which were there. This starts with the outer lid, the metal framework, the plane of the this one containing the audio seed XIAO ESP32 chip, the ball bearings, the motor. You have the upper clamp for the motor with the belt. You have lower clamp with another belt. You have the washers. You have the bottle. You have the upper lid, and this is just no, wait, 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 wait. and this is the final view of the product, and this is the drawing, and this is how the product looks like. You can compare it and you can check it how well it is and how it has come out. So thank you very much for joining, and we'll keep on exploring such things later on. Yes, so good night.